Hi, I'm Randall Heyman, a mathematics academic. Thanks for joining me on one of my Corona Help playlists where I make quick turnaround videos to help students and educators during the coronavirus outbreak. If you'd like me to make a video for you, then just comment below any of my videos or drop me an email. I got a comment under one of my videos from Mohammed. This is my video, Fermat's little theorem made easy. So this is not to confuse it with the famous Fermat's last theorem. I have a video on that as well. If you're interested in that, have a look at that. Okay, so I'm not sure what happened with Mohammed because he wrote a comment under one of my videos. In fact, under the video, under the comments under this video, but it hasn't come up. It came up on my phone, but it hasn't come up actually under the comments on the video. So I think he's got some notification change, so I couldn't reply directly to that comment. So hopefully he's going to see this, but if not, some others may find this useful. So okay, let's just start. The first thing to just think about here is when we see 13 to the 36 modulo 19, we're talking about modular arithmetic. If you're not familiar with that, have a look at my video, Modular Arithmetic Made Easy, where I go through a whole lot of foundational ideas in modular arithmetic. Okay, remember this is just this is nothing more than saying let's take the number 13 to the 36, and what's going on here? What's that? What is going wrong here? Okay, 13 to the 36, and we divide by 19, and when we do that, we get a remainder, and that's the answer to this problem. Okay, so how are we going to do this? So we have, so what do we have? I suppose I should do it this way to do it properly. What's happening with my... Having a bit of trouble this morning, aren't I? We have, so I'm doing this all now modulo 19. So we have 13 to the 36. Well, that's equal or equivalent to, it's equivalent to 13 to the 18 times 2, which I'm just using the power rules that you learned at school, at high school, and they apply to modular arithmetic as well. So it's fine now to just go 18 squared, and this is everything I've done here is modulo 19. So what we're saying is the remainder over here, when we take this, the remainder of this number when we divide by 19 is just going to be the remainder of this number when we divide by 19. Okay, good. Now, why have I done it this way? I could have said 39 equals 9 by 4. I could have said 36, I'm sorry, is 9 by 4, or 6 by 6. Why did I specifically pick 18? Well, Fermat's little theorem says that a to the p minus 1 is equivalent to 1 modulo p for any prime p. And I'll put here just at this stage, all we need to focus for a is that a is between 1 and p minus 1. We can extend it a bit, but for this will be sufficient. Okay, so here, so all we do is we let p equal 19 and a equal 18. So Fermat says that, sorry, let's let a equal 13 here, sorry. Says that 13 to the power of 18 is equivalent to 1 modulo 19. So all I've done here is I've just quoted the general, Fermat's little theorem. Here, we've just said, okay, in our case, we want to make P equal 19 and A equal 13. And so what does that mean? Logically, it follows that 13 to the power 8 is equivalent to 1 modulo 19. And if you look up here, I've set this up precisely to use 13 to the 18. Okay. So let me just call this something. So now returning to star, what do we have? Well, we have the 13 to the 36, which is this bit over here. So I go across here to 13 to the 8 squared. And now this 13 to the 8 here, 13 to the 18, I'm sorry, 13 to the power of 18 is just 1. So I'll just write it in, 1 squared. And 1 squared is just 1. Modulo 19. So this is saying if we take 13 to the power of 36, we divide by 19, we end up with a remainder of 1. And we've used Fermat's little theorem, which I think the question required us to use. So if I was marking that, I'd give that a tick, give it 100%. So I hope that's helped Mohammed if he finds this video, and anyone else who's for this who finds these sort of questions challenging. If you've got any questions on maths, just comment or email me and I'll try and help you out.